Okay, welcome back. This is a video on solving system equations using the substitution method. So here's the system of equations. We got a y equals 2x plus 3 and a 3x plus 4y equals 7. They're both linear still. I think I said in class that we're going to just do linear equations. We could obviously graph these if we wanted to, but we're going to do this a different way. So the idea of substitution is you use one equation to solve for a variable, then you substitute into the other equation what you found out y is. So notice this one is already set up in a nice y equals position, right? So it already know that y, according to this equation, y equals 2x plus 3. So what I'm going to do is I'm going to take this equation, I'm going to rewrite it as 3x plus 4 times something equals 7. And the reason why I leave a big gap there is because what I'm going to do is I'm going to take out the y, and I'm going to replace it with what this equation says y is. So since this equation says y is equal to 2x plus 3, I'm taking out that y and putting in a 2x plus 3. Because again, this equation says that that's what y is. So then I've created an equation that only has x's in it, and so I should be able to solve this. So that would be 3x plus 8x plus 12 is equal to 7. I can combine like terms. 3 plus 8 is 11x plus 12 equals 7. Subtract 12 from both sides, and I get 11x is equal to negative 5, which means x is equal to negative 5/11. Okay, so you can see this method has no problem with coming up with solutions that are not lattice points. And so if we would have graphed this one and found out, it would have been hard to tell that the x coordinate that was working was negative 5/11. So that's one of the shortcomings of the graphing method, and this one does not have a problem with it. So my answer for x is negative 5/11. But of course, in order to find y, I also need to know y. So the nice thing is I already have this set up for finding y, right? So I can just say y is equal to 2 times negative 5/11 plus 3. And that means y is equal to negative 10 over 11 plus 3. And we can combine those. So that would be y is equal to negative 10 over 11 plus 33 over 11. If I add those two together, I get 23 over 11. So my solution is negative 5/11 for x and 23 over 11 for y. Isn't that fun? So that's solving system equations using substitution. Let's do a couple more of these. Let's say I have x is equal to 2y minus 4, and down here I have x plus y is equal to 11. Okay, so there's again a system of equations. This time, the first equation is solved nicely for x. So it makes sense to substitute in for x. So I'm going to take this equation and rewrite it as something plus y equals 11. And I'm going to replace that. So I took the x out. I'm going to replace it with a 2y minus 4. So of course the parentheses are artificial. They don't really do anything for us because there's nothing but addition and subtraction here. So then I'm going to go ahead and add 2y and y. That would be 3y minus 4 is equal to 11. Then I'm going to add 4 to both sides. So that would be 3y equals 15. Divide both sides by 3, and I get y is equal to 5. So part of my solution is y equals 5. To get the other one, I just plug back in. So that'd be x equals 2 times 5 minus 4. So that'd be x equals 10 minus 4, which of course is 6. So my solution to this system of equations would be 6, 5. Okay? What if they don't set it up nicely? What if I have like x plus y equals 10 and 2x minus y is equal to 9? Okay? I can still use the substitution method because I could take this equation and rewrite it as y equals 10 minus x, just by subtracting x from both sides. Oops. So that then I can come down to this equation and rewrite it as 2x minus something equals 9. So I'm taking out the y, putting in what y is. So I'm going to put a 10 minus x there. So then I get, and I'm going to have to distribute that negative there. So that'd be 2x minus 10 plus x is equal to 9. So I'm combine the 2x and the 2x and the x. So that'd be 3x minus 10 is equal to 9. And therefore 3x is equal to 19, because I added 10 to both sides. And x is equal to 19 thirds. Okay, once again, I got to find out what y is, so I go back up here and say, okay, y is equal to 10 minus, well, 19 thirds apparently, which means y is equal to 30 thirds minus 19 thirds, and that would be equal to 11 thirds. So once again, my solution set would be 19 thirds, comma 11 thirds. And that, my friends, is how you do the substitution method. The key is taking one of the equations and solving for one of the variables and then plugging into the other equation. Okay, so I'm going to go ahead and end this. This is a short one.